Hello world, welcome back to Boolean Maths. And today we're going to be discussing circles and inscribed angles. Let's get to it. What is an inscribed angle? Well, one thing I wanted to point out here first is when you're following along these videos, you can see the whole slide here. I've got some definitions. You could always pause the video, take some notes, and I'm going to just dig in here. So let's talk about what an inscribed angle is. Well, this is an inscribed angle. So if you wanted to get slightly more technical, the vertex of said angle is on the edge of the circle. And it could be formed either by two chords or what you would call their those rays would function as maybe a secant because it goes beyond the edge of the circle, so there'll be like a line or a ray. But the whole point is that the angle is like literally right on the edge of the circle there. Okay, and then another thing that you get when you have an inscribed angle is something that's called an intercepted arc. Now, an intercepted arc is contained within the sides of the circle, so within the sides of the angle. So when you have that inscribed angle, it intersects the circle in these two places, and the arc that is formed by that inscribed angle is called an intercepted arc. So it's kind of like it's captured. All right. So the definition is there the arc that lies on the interior or in the interior of an inscribed angle and has endpoints on the angle. Now the big relationship that is formed between the inscribed angle and its corresponding intercepted arc is the following. You would say that, just write it just in English. So inscribed angle is equal to 1/2 the measure of the intercepted arc. Okay, so if we were to, we could give these points. That's an interesting thing that appeared there. So we're going to call this A, we'll call this B, and C, C. And you could say that the measure of angle A is equal to 1/2 the measure of arc BC. In this particular diagram, that's what we'd be talking about. So even though I just wrote that out in English, it's probably better to think about in terms of those letters up there. All right, let's move on. So we have some examples here. I would encourage you to pause the video now and try to do these on your own. Welcome back to those of you who paused the video. Let's take a look here. So they want us to find the measure of angle B. Angle B is inscribed and it's across from a 60-degree angle. I'm sorry, 60-degree arc. Remember, that's an arc measure, not a length. So that would mean that this is equal to 1/2 of 30. Sorry, that's the answer. 60 degrees, which is 30 degrees. So the measure of angle B is 30. Now, the measure of arc RT is equal to, well, it's going to be, we know that 1/2 of RT is equal to 63, right? That's angle S there. So that means that the angle, that the arc measure must be double that. So we could write the relationship down. I mean, you know, one thing that you could say is like, I know that 63 is equal to 1/2 the measure of arc RT. So then you just double both sides times 2, and then we know that it's going to be 126 degrees. So yeah, it's 126 degrees. I like to circle my answers. It's fun. All right. So yeah, when you look back at what we wrote here, some people like to think of the relationship also as the measure of the arc, the intercepted arc, is equal to double the angle. I think you've seen relationships like that elsewhere in geometry, where you could just, instead of thinking as the 1/2 thing, you can think of double. All right. And lastly, you don't have to write an equation for each of these. I mean, some of these it's just pretty clear. I mean, this inscribed angle is 57, so the the corresponding intercepted arc is going to be double 57, which is 50 plus 14 is is 100 plus 14, and that's 114. Okay, so equals 114 degrees. Moving on. Oh, Lord. All right. Next. So now, something that you could probably predict, and I would encourage you maybe to pause the video, is what if I have two sides, right? Like I have this one, AB, and then I have this other one, AC. So I have two sides of an inscribed angle that end on the endpoints of a diameter. So think about that for a moment, and come on back. Now, if you were pausing the video and trying to make some assumptions, we know that a diameter cuts a circle in half, and that makes that 180 degrees. So if your angle is across from 180 degrees, then you would we would know that our angle is equal to 90 degrees there. So so yeah, and that's just the property of the endpoints of your inscribed angle being on the endpoints of a diameter. Shared arcs. Again, you might want to pause the video and see if you can predict what I'm going to say, but let's talk about, so pause the video and see if you can make any assumptions about angles that, inscribed angles that share an intercepted arc. Okay, well, if you did that and came back, let's take a look at arc CD here, and we know that the two angles that share arc CD are angle A and angle B. So angle A and angle B both share that arc, and because they both share that arc, they must have the same measurement. So so we know that from this particular situation that angle A has to be congruent to angle B. What else is congruent? You guessed it. Angle C and D. Why are they congruent? Because they both share arc AB. So, and angle C is congruent to angle D. So again, if you have multiple inscribed angles and you just happen to see that they share an arc, then that's a way to determine that those angles would be the same. So just be on the lookout for something like that. So you might see a problem that looks like this. They say, what are the measures of angles R and T in this particular situation? So here's R and here's T, and they both share arc SU. That means that angle R, we know that angle R is congruent to angle T. So that means the measure of angle R equals the measure of angle T, which equals, it's going to be 1/2 of 139. So it's going to be 139 divided by 2. I'm not messing around here. 139. That's not a 9. Divided by 2. 69.5. All right. Equals 69.5. All right. There's that. Moving on. So another thing to just ponder, and I'm not going to get into the proof behind this. You can try to prove this on your own. It's definitely very provable and quite, I think, in a very easy way. If anyone wants to see it proved, let me know. Okay, so the property of an inscribed quadrilateral, that means that every single vertex of the quadrilateral lies on the edge of the circle. Actually, any shape that's inscribed, and I believe we've talked about this before, but if not, now you know. A shape that's inscribed inside of a circle. Scribe means to write in. It's on the inside. So it's when every single vertex lies on the edge of the circle. So if you have an inscribed quadrilateral, there's a fun property that emerges. And that property is that the opposite angles are supplementary. So let's just point that out. Opposite angles are so in this particular instance, you would say the measure of angle D plus the measure of angle B equals 180. What else would have to be true? You're right that the measure of angle A plus the measure of angle C equals 180 as well. Nice. All right, moving on. So yeah, what we have here is that the opposite angles are in fact supplementary. So we're going to write down the relationship 62 minus 5x plus 133 equals 180. Combine our like terms, we have negative 5x plus 195 equals 180. Subtract 195 from both sides, minus 195, and we get negative 5x equals negative 15. And that means x is equal to positive 3. So let's just make sure that worked out. So when we plug in positive 3, that's going to be 62 minus 15 plus 133. 62 minus 15 plus 133 should equal 180. Cool, we did it right. All right, so hopefully that was helpful. And yeah, have a good one.